Hi, everyone. Thank you for joining me today for my presentation on how AI and platform power are transforming cloud. I want to thank Alibaba for inviting me here today. I look forward to sharing with you some of the findings that we've had over the past few months as AI has really transformed how we think about public cloud and literally how public cloud is being built and brought to you today. So I want to start off really standing back about why cloud was so important for the rise of generative AI. First of all, you had in the run up to this generative AI era, a lot of experimentation, a lot of work with specialized data scientists and model operations teams who were using some of the cloud platforms, plenty of tools out there that have been available for a number of years, including custom silicon for AI and so forth. They were working on these things, but it was very bespoke, very specific, very focused on particular needs, particular models. It was time consuming. It was difficult to get things into production, to test their validity, and so forth. What the cloud providers offered, of course, was the pay per use, a model that had been around since the existence of public cloud, and it allowed customers to begin to experiment without making big investments upfront. At the same time, you had existing GPUs from various silicon manufacturers, as well as increasingly from cloud providers themselves. That provided some additional momentum for early adoption. And then you had managed AI services that could go into production faster. Again, this predated the rise of generative AI. They were around, people were starting to use them. They would be, again, a specialist group within the organization that would be focused on these things. But gradually, the stage was set for a much wider spread adoption of generative AI once the use cases and the validity and viability of all that became clear. And of course, one of the most important factors around the rise of cloud and AI is the fact that the data that you need for training models and doing things at scale is actually available in the cloud. That is one of the primary motivators for people to move to the cloud. It has a great scale. It has a great set of capabilities that would transcend any typical organization's ability to do that within their own data center. So if you put all those things together, the groundswell of pay per use, the ability of model ops teams and data scientists to start to get to work on these, and now the data coming into scope, you have with the rise of generative AI, the rise of the AI cloud. Now, what do we mean by that? Like the AI cloud is, I would argue, a very distinct development in the history of public cloud as we've known it so far. You had the rise of public cloud at scale on x86 technologies, then on ARM technologies, more recently RISC-V technologies, as well as custom silicon around AI and special purpose AI-oriented silicon around GPUs. This diversity of silicon allowed a certain kind of separation, but with different types of workloads, a kind of commodity cloud, if you will, of network, compute, and storage. The mainstream applications that and data that most organizations need day to day, but also distinctively within that, a set of capabilities of infrastructure that was well suited for AI. And now with greater investments going into GPU specific data centers, we're now seeing this rise up at scale. And these are actually physically different data centers with different racks, different cooling needs, different scale in order to meet the demands for some of these new generative AI services. And again, cloud provides the basis for all of this, right? So if we talk about the AI cloud, most obviously it would be about the availability of these GPUs, big technologies, big breakthrough scale, lots of capability. It just wasn't there in the mainstream in the past. With the rise of generative AI, and the ability to harness that capability for any number of different business use cases, there was a big rush towards getting those GPUs. And that was, of course, the big focus of the cloud providers was to provide those at scale because they are such big organizations. They have huge amounts of capital. They have control of various complex supply chains. They could bring all that to market. So just there and then, in terms of the GPU availability, cloud providers were absolutely fundamental just from that standpoint alone. But there's a lot more to the AI cloud than just the provision of GPUs at scale. If you think about the data prep workloads, they need a lot of throughput. They're complex. They operate differently than traditional workloads. The cloud providers, because they have the vast amounts of data from their customers available to them, they can use that data as leverage to provide at scale certain kinds of services that might have been specialty demands a few years ago, but are now mainstream, right? So data process pipeline services, coupled with that big storage, that's quite distinctive in what the cloud providers can offer. Inferencing, right? Okay, we've got this model, it's trained, we want to bring it into production. We need now inferencing to make that viable and impactful day to day. Cloud providers have been able to engineer low latency concurrency. Concurrency is really fundamental to how AI workloads operate, of course. Cloud providers are able to use their investment capabilities, use their engineering skills to be able to bring that to the market and allow customers to tap into this in ways that are quite important. So specialized inferencing services. So you have the raw GPUs, you've got that raw power, you can prep that data, put it through the pipeline, and then have the inferencing around that. And then lastly, but also critically, cloud providers have hardware abstraction models, abstract layers for model compilers and efficient AI. And again, this is also important. Some cloud providers are focused on models that they've developed themselves. Some others are focused on a more heterogeneous approach, bringing to market whatever the models are popular or where they can establish some partnerships. In some cases, it's both, something, a homegrown model, but also something that's available. And now we've seen that capability being turned into something around delivery to specific use cases, such as a model as a service for particular industries with industry-trained models. And so again, if you want to look at the net result of this, is that suddenly what was a specialized undertaking of a few data scientists and special platform team personnel supporting them with some particular data for some very narrow use cases are now actually transformed into an enterprise-wide effort with access to the GPUs, with access to the data prep, with access to the models. And suddenly all of this can be brought to bear on a whole number of different use cases that might not have been seen as viable or cost-effective a short time ago. Sometimes that can be consumed as software as a service from a cloud, but critically here, AI is also putting AI innovations directly in customers' hands. That's happening in a few different ways. The first is that Turing bots are available, and Turing bots is what we at Forrester call AI-assisted development. Sometimes these are kind of contextual driven, prompting for a developer. Sometimes they're completely automated elements. Sometimes, very often, a combination of both. But the Turing bots are really simplifying a lot of the drudgery of a lot of core development tasks and allowing developers to focus on what's more differentiated for them. Also, even maybe just as critical is that the cloud providers are offering services that allow their customers to build their own AI apps. And that's critical as well. A series of managed services and developer integrations have enabled people who might have otherwise have been straightforward engineers on any number of more commodity software projects now being brought to bear and delivering AI capabilities for their own organizations, making use of some of the managed cloud services around AI capabilities as well. And now emerging, as well as that, are agentic capabilities, which enable customized intelligent workflows at scale, where essentially you're taking what might have been a discrete robotics process automation in one era, kind of assessed manually and built manually and plugged in and maybe integrated with some APIs. Now with an AI, an agentic type of approach to AI, you have some of those various scenarios of next best steps, actions, and so forth being embedded within the intelligence of the workflow itself. That's new, that's emerging, and being adopted quite quickly and being brought to market both by providers of specialist types of enterprise software, but also putting that in the hands of cloud users themselves, cloud customers, to build their own, take their own workflows and automate them using some of these AI agentic capabilities. Now, the global perspective is key here. We have a global market for cloud. It's been transformed over the years. Great respect. There are a handful of dominant players at scale, but within that wider picture, there are a number of different cloud providers with a regional focus and technology focus and so forth. And all of these create a public cloud platform ecosystem that cloud customers, enterprise class, large government organizations can take advantage of. Now, at Forrester, we narrow the focus to ones that we think fit an overall global perspective, which is, in our case, 9. So we have to look at a public cloud platform that has a global presence. Every vendor involved has to have a standard software foundation in which enterprises can build complete applications that developers can freely access via self-service interface. In other words, you have to be able to build on it. It has to have pay-per-use billing. It has to have resources on demand. And you have to be in at least 3 different regions: North America, Europe, Middle East, Africa, Latin America, and Asia Pacific. So that you have to be global. And there are very competent cloud providers that don't meet all of those criteria and therefore could not be included in this evaluation. But for the global perspective, this is the criteria to be involved. You have to have a wide and generally available development and infrastructure services. So you have to be able to do that natively on the platform. And again, there's a lot of different services coming out all the time from all the big cloud providers. We had to draw the line at August 20th, 2024 and say, if it was generally available by this date, that's fine, we will include it. If it was just announced but not yet generally available, we could not include it. So it's a point in time evaluation necessarily, but one we think holds up as for this period of time to get a sense of what the key dynamics are in the market, what the capabilities are of some of the leading players. And again, to be involved in this wave, you have to be enterprise grade. There's no one who cannot meet that standard, and then meeting that with the regional diversity as we described, right? So we want to see that enterprise adoption. We want to see those products there. And then we also want to see strong interest among Forrester clients, which in the case of the global cloud providers, that's of course generally true. And when we look on to the a little bit more closely at this, when we evaluated the market, we had a number of current offerings that encompass the entire technology stack. Each criteria had at least 5 services within that. You had about 9 providers included in the wave. That's easily about 1,200 different distinct services. As I mentioned, the cutoff date was August 20th, 2024. So that is a big sweep. It is a very dense evaluation, but one that we think that was worth doing because our customers need to have a great understanding of what actually is available in the market to them today. So we have what we call 3 categories here: leaders, strong performers, and contenders. Again, is the axis on the left is about the strength of offering, what's capable, how, the breadth of services and so forth. And the axis to the right, the lower axis, the strength of strategy, how effective are the various providers in coming to market with this. And again, these are all enterprise players. They all have something to offer to customers and enterprises and large government entities in various regions of the world. We evaluated them based on their relative strengths to one another, which has to do with how much scale, how much strength of offering, and also their strategic viability, how they bring that to market today and where they're going to go in the future. So if you look at the criteria that we have a little bit more closely, you'll see that we weight them as well. So for the current offering, and there's quite a number of them, as I mentioned, we weight them fairly evenly across. There's no standout over one or another, but 5% for database, analytics, data integration. But if you put all those together, database, analytics, AI development, AI applications, data governance, you start to see how that adds up to a kind of an AI readiness, AI capable story, right? If you have the database, analytics, data governance, and so forth together, that then gives you a kind of a takeoff point for these new AI workloads, as well as the traditional network compute and storage. And clearly, delivery from an infrastructure standpoint is critical. It's an infrastructure that's the core of the public cloud by definition. So we looked at container and Kubernetes services, serverless and fast services, and of course, development generally, both traditional and AI assisted, and the automation of developers through CI/CD and various DevOps support is also critical. So again, you spread this out, but you can find a kind of a cluster of capabilities and weighting. You'll see how if you add up the data and AI related elements, how AI could play a role, the rise of the AI cloud could be captured in this survey. The additional services, mobile, yes, that's a factor. Those are a little bit less weighted because mobile services is something that cloud providers obviously do, but share that market with other providers. Migration services, again, cloud providers offer them directly. They also work with a lot of partners for that. Modernization. I'll call people's attention to things that are weighted a little bit more here. Compute and storage and network and security. These are obviously critical for any workloads, but when we're discussing the rise of the AI cloud, you're going to need to have compute that has a range of everything from high performance computing and specialized operations, as well as the kind of straight ahead core compute services that run a lot of day-to-day workloads. Storage is ever more important in the rise of the AI cloud era. And I would say also networking and content delivery services, especially when you get to intelligent edge and inferencing, these things become important. And of course, security services and integration also play a big role in making a cohesive enterprise estate. The modern IT enterprise is highly asymmetrical, highly differentiated. It might include software as a service. It might include very specific things at the edge. It might include cloud provider services that provide a platform that the user builds out. It might also provide a serverless container runtime with highly abstracted from the underlying services. It may well include all of those things at once. So that's something that's important to keep in mind. And Forrester customers have the opportunity through our online tool to go and weight these various characteristics according to their own needs. So you could dial up mobile services or dial down edge services, if you like, in order to capture the differentiation from one provider to the next. The weightings that you see in the Forrester Wave chart are ones that we've chosen, but by no means are Forrester clients limited to that choice. So moving on, we also, it's important to note, include strategy in this. And if you look quite heavily, of course, innovation is weighted as well as vision. Why is that? Well, if you're going to be taking your customers through a big technology transformation, you have the opportunity to stake out a whole roadmap for a whole qualitatively different new way of doing enterprise IT. So the innovation weighed out very heavily for us, as well as the vision. Where are things going? When you cross the technology threshold, yes, you can deliver the technology, you can enable the customer, but when you cross this threshold, it has lots of implications for how business is going to be done, how digitalization of the enterprise is going to be done. You have to have a role in staking out that vision for the customer. So therefore, vision and innovation were weighted quite heavily, as well as, of course, roadmap. And pricing and flexibility and transparency, also important, because AI workload pricing is new. It has to be assimilated by the customer. It has to be well understood by both its providers and its consumers. And therefore, that also carries some weight. And of course, community participation, given that open source is so fundamental to public cloud, is also a key consideration. So again, a quick look back at the wave as it stands. And moving on to the big takeaway, right? We have the public cloud platforms overview. We have some key takeaways I'd like to put across to this audience. Cloud strategy is now inextricable from AI strategy. Now, it may be a negative implication in that I have a cloud that I want to have a series of mainstream enterprise functions, enterprise apps, core workloads, virtual machines. I'm not going to do AI right now on this platform. I'm going to choose another platform. I might do this myself in a data center, or I'm going to go to a different cloud provider to stand up my AI. So it doesn't mean that whatever cloud provider you might be working with today is the one you're going to buy AI from. We see multi-cloud as now predominant. and people are making choices, and the choices have a number of different factors. That may be an assessment that a particular cloud is adept at providing the workloads that they would like around AI. There may also be a geographic component. They need to be in one region of the world. The one cloud provider has an outstanding set of capabilities. The other cloud provider has a more limited presence. That might be a deciding factor for them. The AI must factor into that, and not just who can provide those services in the abstract, but do they actually have the capacity in place to provide the new GPU data centers? Can they do that in a timely fashion? Can they do that in a cost-effective manner? So those are cloud strategy and AI strategy are absolutely inextricable today. Public cloud options are broader than ever, and the breadth of offering is different. I mean, different cloud providers interpret that differently. Some cloud providers orient on providing a lot of technology infrastructure for other technology companies, software as a service, or specialists in one branch of industry or another. So they have a set of broad offerings for that particular industry. It may not be relevant for everyone, but it is broad. So that may also drive a decision one way or another. An assessment of cloud and financial services in one part of the country, part of the world, might be different from a manufacturer in another part of the world. So these are all contingencies that anyone has to look at when they're considering their public cloud options. Multi-cloud and hybrid are the norm. Just about every cloud provider allows some ability to interact with or manage the Kubernetes control plane, for orchestration of containerized applications at scale. That's fairly straightforward today. Most cloud providers have, either directly or through partnerships, some ability to operate in the data center and at the edge. So that is the norm. People want that kind of diversity, or at least the option to have it if they don't yet use it today. Cloud providers have adapted to that very systematically over the last 2 or 3 years. That's a big change we saw in this cloud wave in relation to the last one. Now, more specifically, there's some other takeaways that I'd like to be able to bring in here. So we have the key takeaway about the serverless first and only cloud is here, right? We have Kubernetes, functions as a service. Those are now more or less implementation details that are abstracted away with serverless container runtimes and so on. We see platform teams embracing that complexity if and when they need it. If they decide that they have to build out in a certain scenario, say manufacturing, where there's a lot of organizational or company-specific integrations that need to take place, people will then get hold of some of these platforms and build them out themselves. Elsewhere, there's a growing tendency to embrace these more abstracted serverless. The cloud customers want services based on non-proprietary and open source services, and they want to avoid complex platform builds out and integrations. What do we mean by that? If you're a cloud customer and you want to make sure that you're going to move forward on open source, yet you don't want to wrestle with the complexity of open source yourself, you're going to look to find a cloud provider service that has open source software underneath it. So you can find any number of serverless container runtimes that have Kubernetes underneath. That is a form of assurance to the consumer because they understand that the Kubernetes cloud native ecosystem is multi-vendor, it's collaborative, and that the innovation from this industry-wide embrace of this open source software is a reasonable assurance that abstracted service they're using is going to be a good basis for them. So yes, they want to have a more abstracted serverless approach, but they also want to have the cloud native underneath that to make an open source underneath that to make sure that it's going to be consistent over time with the innovations in the industry overall. And the serverless GPU offerings are multiplying with innovative and machine learning and deep learning and development, as well as model as a service. Those are all key elements here, right? You want to have these GPU services. As I said, initially, early attempts at AI necessarily required specialized personnel, data scientists, specialized platform team people getting together, creating these kind of niche operations within an organization to build models, train them, bring them to production, so forth. Serverless GPU can provide a whole different set of options for that, right? Lots of different machine learning options, deep learning options, model as a service, very different today than it was just 2 or 3 years ago as a result. And I want to just focus in a little bit more on this question of serverless GPUs, because again, pay-per-use, I mentioned that earlier. That's back here. Pay-per-use was an initial value proposition of the cloud back in its early days. Instead of lots of capital investment in a given data center, you could actually pay per use and basically don't pay for anything you don't need. The same is true for GPUs. You don't have to invest in an expensive GPU data center. You don't have to make the kind of investments that only the large hyperscalers are capable of doing at scale these days. You can turn that on a pay-per-use within a cloud console that you're already accustomed to. The existing GPUs and custom silicon have created a lot of momentum for this, right? There are important GPU providers who have gotten a lot of big demand, but there's also quite a number of initiatives around custom silicon, some existing in the market today, some coming into production soon, which is going to create silicon diversity within the AI cloud itself, as opposed to the overall silicon diversity in the public cloud. That's very important for the generalization and accessibility of AI services. And again, coming back to this question of speed of adoption, these managed AI services can go into production much, much faster than the previous data science and MLOps teams, right? The pay-per-use allows you to get going right away. It also gets you going a lot faster. So that's a big change that we're capturing in this public cloud wave. Another key takeaway from the wave that I'd like to give people is that the cloud security offerings around security and responsible AI are ramping up, right? So cloud security offerings are now very extensive, and certainly cloud customers can go and find trusted third parties that they prefer to work with or like to work with alongside their cloud providers. That's fine. But I think a lot of cloud customers will welcome the fact that their cloud providers are continuing to expand the number of cloud security services available to them. These extend from the endpoint to the core infrastructure, and they increasingly take on sovereignty in terms of how they're delivered and packaged to meet various needs. More and more pre-built security and compliance offerings are available today. So essentially what that means is that, say, a cloud architect or an enterprise architect, when they're planning out what they want to do in cloud and where they would like to build out in a particular direction in terms of capabilities, in many increasing numbers of cases, they can look at some of the cloud provider offerings that are related to particular industries, such as financial services, for example, and know in advance that doing a particular set of services and implementing them in a particular way is available with a well understood pattern, or actually something that's just out of the box, pre-built, compliant. That's an important consideration for a lot of organizations. It speeds things up in terms of bringing them to market. And responsible AI, there's a lot of activity here, more than we could get into in this session, but there's a lot of efforts around standards development with many, if not most of the big cloud players involved. A lot of work being done on risk management, which is obviously going to be more complex as the questions of model provenance and integration with existing data come in. And of course, privacy and security, a longstanding concern for IT, generally has a particular focus around AI services. So just to focus on another key one in particular on this multi-cloud security and responsible AI gaining momentum, I'd like to focus on that a little bit more. You have the cloud AI is moving from scattershot to orchestrated. The requirements of generative AI made it inevitable that the hyperscalers would dominate the AI boom, although there will be some disruptive upstarts. And the cloud evaluation of cloud provider AI offerings necessarily is going to focus heavily on the infrastructure firepower of the cloud providers in order to bring these services into market more readily. And we looked at the AI-assisted Turing-bot development tools for general application development, lots of services for developing AI applications with different agents. And we looked a lot at the Gen AI enabling technologies of various sorts, such as retrieval augmentation generation and others, various kinds of ways of doing embeddings and data prep. All of these factored into our evaluation of cloud AI. Because again, as we started off talking about, the availability of the GPUs, the availability of cloud scale, the availability of cloud data was an important takeoff point. But for delivering these capabilities to market, the cloud providers have something else to offer, which is vast experience in integrations, bringing things to market, making all these services work for customers in increasingly self-service, highly automated fashions. So one way to think about that is we have the intelligence or the AI in the cloud, which is where I'm running my GPUs, but there's also the intelligence and AI of the cloud, which is, of course, the ability of the cloud providers themselves to bring to bear their own automations and intelligence and how they do cloud operations. And most importantly, in this context, how they're doing that for AI itself. Now, when we're looking at the future here, where we're coming out here, is that cloud native and generative AI are going mainstream. And this is very short term, right? Picture. We've got cloud native ecosystem that is maturing around open source and so forth through AI assisted development. And we're going to see more and more automation that's going to increase the productivity of IT platform teams and building a scale of Agile plus DevOps. And this is going to hit both sides of DevOps, right? The developers are going to have their own AI assistants. They're going to be able to bring AI to bear at scale. That's going to be important, but also the operations teams are going to be able to take advantage of the intelligence of the cloud, increasingly, I would say, agentic AI, in order to streamline cloud operations and point cloud capabilities ever more towards the consumers on the business side. And that leads us to business opportunity evolution, because tech leaders are going to leverage cloud opportunities to much more closely align IT to business outcomes through a much more product-centric operating model. What does that mean? It means that the AI services of the cloud, as they move out of the boundaries of enterprise IT as we've traditionally known it and more towards self-service by the business units and other organizations outside of IT, tech leaders will be that enabling function for the business, but in a much more dynamic way than we've seen before. And you can see this taking place with business intelligence and workflow automations and other capabilities that are going directly into the hands of the business user, as opposed to being set up by the platform team in advance. And at the same time, the AI everywhere cloud services approach are going to dramatically improve proactive operations. I mean, this is going to help business operations as much as IT operations. And there'll be a very good feedback loop now, because AI will help, in a sense, mediate the differences between how the IT has to be organized and how the business has to be organized as process automation comes into focus and is implemented. And I think there'll be a new set of partners all around this, right? Open source is already a partnership ecosystem that's going to continue. And there's a big open source AI ecosystem that's really taking shape today very rapidly. And that's going to be another feedback loop back into product development for the cloud providers, but also provide opportunities for users themselves to embrace these technologies and shape their own fate if they're so inclined, using cloud technologies and others. So that means that cloud providers are going to move closer to the business outcome. They're going to try to address this last mile with some of these partners and collections of their own services. So again, the more generalized AI services become, the more self-service oriented they become, the wider the partner ecosystem takes shape around these capabilities. So to conclude with, I want to talk about the future of cloud as something that's going to be abstracted, intelligent, and composable. By abstraction, I'm referring here to the Kubernetes-based cloud-native ecosystem, which is the area on the right, which has a diverse ability to run on different infrastructure, can run on the edge, the public cloud, private cloud. It can run at the edge, like more on the operation side, as well as the experience side. It can have a multi-cloud dimension and an industry cloud dimension with specific industry needs being built on top of this common platform. The intelligence is both in the cloud and of the cloud. The intelligence in the cloud with GPU capabilities, enabling AI-assisted development and so forth, but also the dynamism around cloud operations that's also taking shape. And the composability comes in because if you have a common cloud-native ecosystem, which is at the core of all or most of a lot of the AI innovation today, you can then extend that common infrastructure towards specific domains or specific use cases, whatever sort makes sense for you as an organization. For a manufacturer, it might be digital twin technology in making use of some of the AI capabilities around there. For a user, it might be a series of low-code, customer-facing, business-facing applications that make AI very integral to the day-to-day functioning of an organization or how an organization goes to market. So this abstraction, intelligence, and composability, which was taking shape before the generative AI movement, I would argue has now got a lot more momentum behind that, because what used to seem like a series of abstractions and possibilities are now things that people are working through every day. And what we've tried to do with the Forrester research over the last 2 or 3 years is to be able to understand these dynamics and all their facets. Forrester colleagues have embraced a lot of different research streams around AI and models and so forth. Here today, we've talked about cloud because the public cloud providers have a unique role in bringing this to market. So I want to thank everyone for their time and allowing me this opportunity to share my work. I always welcome feedback. Please reach out. Thank you very much. And thank you, Alibaba, for inviting me here today.